remains, in spite of my love for the web, iOS has a special place in my toolkit, in my heart. And we're going to talk about how to integrate your iOS applications to backend REST services, okay? Which is something that happens nearly all the time. I mean, it's like we live in a connected world. We have to consume data. We have to send, receive, and there's a lot of questions that pop up, and I hope I will be able to bring some answers. This is based on my own experience, as usual. So for those who haven't been to any of my talks until now, my name is Adrian Kosmaczewski, Polish family name, Argentine origins, and Swiss passport, so very complex, but that's here it goes. Kosma Software is the name of my company, and you can find me on the web on any of these fine places. So you have now 1 minute to follow me on Twitter, like my Facebook page, and there you go, you can do it. And send me an email, of course. And you can find me as well on GitHub, LinkedIn, SlideShare, Identica, FriendFeed, Stack Overflow, and whatever. I mean, whatever I see that I can grab the Kosma name, I will have it. So there are many questions that I would like to know you better. So, raise your hands who is a web developer, strictly web developer. Oh, sizable quantity, like half and half. iOS developers? Very good, good. Welcome to the joint. API designers is really a subset of web developers, people who are really designing REST APIs or SOAP web services. Please raise your hand. .NET, very good. Rails or Django, open source stacks like that, and PHP. There you go. Well, there will be as well quite a bit of information for you, I hope. So let me tell you a story, okay? This is the story of nearly most interesting iOS applications. Sooner or later, you will have to connect to some backend server. You will have to read some information. You will have to get the weather, the stocks information. You will have probably to connect to Twitter. You will have to probably connect to Facebook. And there's a lot of APIs. We're in a world where we can consume information from so many sources, okay? And we have to connect and make our applications being able to consume all this data. And if it's not public APIs, we might have internally in our own company, you know, that good old REST service or SOAP service. For those who are in the .NET stack, it might be more common to have a .NET SOAP service, right? And you have to make your iOS apps connect to that backend data. So this is the story we're going to be talking about. So of course, this is the situation. The situation is always the same, you know. You have all your mobile agents, they have to consume these apps over the web and be able to retrieve information to some backend store. And that raises, of course, lots of different questions. The first question is, which format should we send our information through? Okay, which libraries could be using? I mean, from iOS, which libraries should I use to connect to a network? Which libraries should I use to consume JSON data? There are so many JSON parsers right there, so many different choices. There are so many XML parsers for iOS. Which one should I choose? Which one is faster, better, less memory? You know, all of these things. How should I architect my application to be able to consume all of these services and be able to extend that application later to support other APIs as we move forward? So what are the best approaches? So basically, there's a very bad news. As I said to someone this morning, I don't know if this person is in the room, I said there's no best. Okay? There is no best. Every time you have to consider the requirements of the solution you are building, you have to consider the situation, the economy, you have to consider the budget that you have. How many people are in your team? How many of them are proficient with iOS or so the server-side technologies or JSON or XML? Okay, there is no best. So I said, how can we provide solutions? I mean, there are far too many options that we should consider. Okay, is REST or SOAP that we should take? Is XML or JSON that we're going to consume? It's synchronous or asynchronous? Well, this one is actually quite quick and dirty answer is asynchronous in general if you're writing UI code, but you might as well need some synchronous connection in a background thread, so why not using synchronous? So then again, you have to wait all of these things all the time, and it's hard to see how to find the solution for all of that. So my humble proposal is one answer. It's not the answer, that's why I say one answer. It's one possible answer. And it's called iPhone Web Services Client. It's a project that I have on GitHub. It's open source, so you can download it and play with it as much as you want. And basically, this is the logo or icon of this thing. And basically it looks like this. It's an iPhone application, fairly simple iPhone application, that connects to a custom-made web service that I've created in PHP. So it's very easy to install in any one of your own facilities, in your own servers. You can test it to see the speeds and the reactions on your own context, okay? And basically it allows you to specify at any given time. Let me just use the famous laser pointer technology that we have here. We can specify the type of payload that we want to consume from our iPhone application, the number of items that we want to receive, and then you have a long list of items, and you can test how long this takes to upload and parse and display. And let me tell you, the differences between different approaches is stunning. It is not the same to consume JSON and XML, depending on the size of the data that you are managing. So that's why I was very happy to have built this, because it allows me to provide numbers to you. It allows me to give you some situations where one approach is better than the other. It is fully configurable. You can basically specify your own server and you can run it. And of course, the whole code is open source. So if you want to extend this to support some custom situation of yours, you feel free to do that. You can even, I generate basically dummy data with contacts. There's an online dummy data generator that I use that generates 5,000 dummy contacts with fake addresses, but just to have lots of data streaming back and forth. And I have in this application a special mode that allows you to benchmark any possible combination of payload and networking library, okay? So the system is completely extensible in that sense. You can provide any networking library that you want. So far the project supports an SURL connection and ASI HTTP request, okay? Because there are many networking libraries available for iOS as well, each with their advantages and disadvantages. And basically what I do is to mix all of them using different sizes of data. And I did tests of this application, putting the PHP server in a remote, in my remote server in the United States, and I tested this using 3G and Edge and GPRS connections. Okay, so and I did these tests on an iPhone 3G, an iPhone 4, an iPad 1, an iPad 2, and an iPod Touch second generation. So I really have gone gathering as much data as I could to see which combination performs better in which situations. And then you can, of course, send an email to you with the benchmark results. And I gathered many of these benchmark results as well in an Excel file that is available as well in the GitHub repository that you can download, where you can see all the statistics of all the data that I've gathered. Basically, you can connect to iTunes as well, your iPhone, and you can download all the files that are generated every time you launch a benchmark, okay? So there are two parts to this solution. The first one is a PHP server application, okay? So basically you can install it whenever you want, the server of your choice. You can test it in your own conditions with your own network capabilities, with the power of your own server if you want. And the other one is this iOS client, which for a moment only runs, it's only an iPhone application, but it could be extended to be an iPad application if you wanted. It takes as many formats as possible. So just to enumerate, I use 10 libraries for XML, both DOM and SAX. So it's very interesting to see how DOM and SAX fare when parsing XML data, huge data sets of XML data in your iPhone. JSON, I'm using 5 different JSON parsers. YAML, why not? I said let's be crazy. I started also working with CSV, SOAP, property list, in XML and in binary formats, and protocol buffers. Who know protocol buffers here? Okay, protocol buffers, okay. There's someone. Protocol buffers is a serialization format created by Google that it's on the open source domain, and it has libraries for PHP and iOS, as many other like C++, .NET, Java, whatever. And basically, it's a binary serialization format. You can take a data structure, you serialize it to binary. It's very small, very efficient, and there are libraries for many different formats. Okay, so this is so far what I've been using in this project. So this is how it looks like in terms of class structure in Xcode. You have deserializers. Okay, so I have basically one deserializer per different per data format that I consume. This way I can encapsulate each one of these libraries into a common interface, and I can basically switch and iterate on top of them to do my benchmarking. Okay, so it's very easy to extend. You just generate a new subclass, and you can pretty much manage any kind of data format that you want. It's extensible, so you add all the formats and libraries that you want, and you can change the size of the dataset to see how different libraries behave in terms of memory consumption or speed of deserialization, depending on the choice that you've done. Okay, so you can go from 1 to 5,000 basically. It's an heterogeneous data source. That means that the same data I provide in different formats, but it's always the same data. It's always the same data. I use XML and JSON libraries, as many as I could find, as I told you, and there's nothing better than a demo. So let's go to that. So far, so good? It's interesting? Okay, then let's move forward. Otherwise, I leave the room and that's it. So I'm going to switch from my iPad to my MacBook Pro, and here we are. So here I have MAMP, which I strongly recommend to use if you are into development. I mean, the web server that is included with macOS 10 is not bad, but MAMP is much better, much more configurable, and much flexible, I found. And basically, I have this program that is running here, which is the PHP program, okay, that returns when you don't provide any formatting parameter. It provides just a long table of HTML, but you can pass format parameters right here. You can say, for example, that you want XML, and boom, the same application will format the data using XML. The same goes for JSON. Here you have format JSON parameter, and I have the same data provided using JSON. Okay, so this allows me to play with different payloads and see how different things work. And you can also specify, for example, the limit of the data. You can also specify 2 items, and boom, you get only 2 items in your response, and so on and so forth. So as you can see, the API is super simple, super simple. And for the Xcode part, here I have my Xcode project. I'm going to resize the window to make it more visible. And here I have all the externals. So as you can see, these are all the external libraries that I've been using into this project. So it also provides you, I think it has a certain value for developers in the sense that it shows you how to integrate external libraries in an Xcode project. Okay, here I've been to the maximum that I could find. I integrated as much as I could in terms of external frameworks, libraries that I could find on the web. Some of them were particularly tricky to get working because the source code was not available. They were old, not updated. I had to go and change the source code to update it to new versions of Objective-C. So it's been a bit of fiddling on it, but it actually paid off fairly well. And then, of course, in my classes folder right here, I have the different controllers of the application. As you can see, in terms of controllers, it's very simple. And I have all the different helpers with all the deserializers that are right here. Okay? And typically, a deserializer, I have this base class right here, which basically has one very important method, which is perform deserialization, which is that method right down, which takes NS data that was returned from the server and will return an NS array with the data consumable in formats that can be consumed by iOS. Okay? Each one of these subclasses, in turn, use the specific format, the specific notation, and APIs of each one of these libraries in an encapsulated way. Okay, so it's easier to manage and to extend. Very well. And how does it look like? Well, very well. I can go to my simulator. As you can see, I've already prepared everything. So I have my client, which is right here. If I launch it, it connects. Well, it crashes. This is the typical. This is what happens when you think you have prepared, but you haven't. So let's try again. Very good. And now it doesn't crash. There we go. And as you can see, I've just loaded 5,000 items in my simulator. Remember what I said yesterday, that testing on the simulator is limited because you have, in this case, I have a Core Duo 2 machine. This is a fairly old MacBook Pro from 2008. Now they come with i7, so you have plenty of RAM, plenty of processor power. So you have to, actually, the funny thing starts when you start using this application into your own devices and you start playing with these formats and you start seeing how these different options behave and change. Okay, so here, for example, I have configured it to use my localhost site. So this is how it goes. Then I can benchmark. This is how it goes. I have this benchmark controller that appears, and when I click on start, all the different options start appearing, as you can see. I can scroll while the thing is moving, so actually it's completely asynchronous in that sense. And it should continue. But then again, well, probably it crashed. No, it hasn't. Anyway, done, and that's it. And basically, that's how it goes, and you can launch this. The tests, this is the second part, so the fourth part. So since I have this solution now, I installed it in as many devices as I could, and I started playing with it. So the devices that I tested so far is an iPhone 3G, an iPod Touch second generation, an iPhone 4, iPad 3G first generation, an iPhone on GPRS, on 3G for the iPhone and the iPad, and all of them I tested on Wi-Fi, of course. And I tested as many combinations as possible with different data sets every time. And this is what it looked like when I was basically doing all my tests at home. Basically, that's what I call iOS developer nirvana. Okay, you've got all your devices running at the same time, making as many combinations as possible of everything, and then gathering all the data and putting everything together. So basically, not only did I test just to get the raw data of times, which is the first parameter that I was interested in. I said, okay, how much time do the different libraries take and how well they fare to each other. I also connected the devices to instruments, and I measured for each one of them, in each device, the quantity of memory that was used in each case. You would say, this guy really has time to lose. Huh? But then again, I mean, it's very interesting in the sense that some libraries are some solutions are mind-bogglingly efficient in terms of memory consumption. Like I'm telling you, 5,000 items, not even 7 megabytes of consumption for binary property lists, but 80 megabytes of RAM for some XML parsers. We're talking about the 10 times bigger consumption of memory. So it's really important to figure out what you're doing, particularly in older devices like the iPhone 3G. Okay, so this is what I was looking for, and I wasn't disappointed. I was actually very happy to do this. And this is where we get to the awesome part. There are many parameters that I try to organize in my Excel spreadsheet that you can find on the GitHub project. First of all, which was the easier one to implement on iOS? Of course, all the libraries are do not have the same interface, the same dependencies, the same requirements. Some of them are absolutely impossible to install in iOS. It's really complicated to get them working. And my results is that the easiest is to go on terms of developer time. It takes shorter with JSON, property list, and surprisingly CSV. The worst were SOAP and YAML. There's only one YAML library. I'm pretty sure nobody will go to YAML, but then again, why not? So I prefer to show it. And SOAP, it's a mess. So the big problem with SOAP being that there's no native support for SOAP on iOS. That will answer probably many questions that you had coming to this session. Forget it. It is hard. SOAP is hard. SOAP and iOS, not friend, not good, no bueno, no señor. So it will be like that. XML, it depends, it's okay. Some libraries are really easy, it's one line of code. Some others are much more complex, particularly the Sax parsers. It gets hairy sometimes, depending on the schema of your XML. Frankly, if you go Sax, you are for a ride, because depending on how you are, you have to manage the state of your parsing and know if you're in which node and which depth of which node, and then you have nodes with the same name at different depths, and they become crazy. In the PHP side, well, this is kind of dummy, but I put it again. I mean, JSON and YAML, of course, but because there's native support in YAML. PHP is not the best for SOAP, but then again, this is again something that only concerns PHP. Of course, in .NET, it's much easier to create. Actually, it's super easy to create SOAP web services. The smaller payload, this is interesting because it has a direct effect on the consumption of bandwidth, and particularly for mobile devices on very slow networks like GPRS, this is very important. CSV, protocol buffers, and binary property lists. Okay, property lists, it's a very important concept, the plist that you are going to see a bit everywhere. Property list is a serialization format used by Apple. Nearly all the XML and settings and configuration files that you can see in Apple products is based on the property list format. Okay, there's XML property lists and there are binary property lists. And binary property lists are super efficient. So if you have control of your server and you want to serve data for iOS devices, personal experience, go binary property lists. It's really worth the try. There are libraries for binary property lists in PHP, Ruby on Rails, Java, Python, and you can basically deliver your data using binary property lists. It works super good on iOS. Which are the fastest deserialization speed? Which is the format that gets deserialized the better and the faster in iOS? Well, it's without any doubt binary property lists and XML property lists. It's in a couple of milliseconds. It's almost as if the data could be directly consumed. As soon as it is located in memory, we can put a pointer on it and we start consuming. It's really interesting to see that. Then we have, in terms of libraries that work very well, I found JSONKit. For JSON, it's my choice. Whenever I work with JSON, I use JSONKit in my iOS applications, and TBXML. TBXML is very good if you only consume read-only data. It's not meant to create XML trees in memory. So these are my two choices when I don't use binary property lists, of course. Then SOAP, surprisingly, very fast to deserialize, and the worst of all of them, if you are using BSJSON, please rewrite your code and get rid of it. It's really slow, actually mind-bogglingly slow. Which is the one that is more portable? This is very important, because depending on the payload that you're going to use, you might want to support as well Android, you might want to support as well other formats. So it's, in this case, property lists aren't appropriate, because basically the only client technology that has support for property lists is Apple, iOS, iPad, iPhone, etc. Okay, so if you really want to go the road of the cross-platform thing, well, use XML and JSON. It's a safe bet. You've got parsers and reading libraries for any library, any platform that you want. Which one is more readable, like human readable? Okay, it's the one that you intercept the payload and you want to debug and see what's going on in the wire. Of course, the binary formats are the more difficult to debug in that sense. It's obvious that JSON and YAML, particularly JSON when it is formatted to be properly read, is immediately readable and very easy to follow. XML first in the middle because it depends on how complex your schema is, of course. Less memory consumption. Binary property lists, big winner, absolutely big winner. The overhead of memory consumption when using binary lists is incredibly low, okay? The whole library takes one method call, it's just one line of code, and you've got your NS array or NS dictionary ready to be consumed. So this is really interesting. Now, on the other side of the equation, you have APXML, which is an open source XML parser that I found on GitHub, plus SOAP. Beware, lots of memory. We're talking about tens of megabytes to one big response, in this case including 5,000 elements. So it's really, really bad. Some really raw and deeply and stupid comparisons, okay? Because I started playing with all this data and it was very fun to see that, for example, binary please are 3 to 4 times faster to deserialize than JSON, that the iPod Touch and the second generation is 25% faster than iPhone 3G. You know, kind of things, the kind of numbers that pop up, but it's kind of fun. The iPhone 4 is 300 faster than the iPhone 3G for these tasks. I was surprised. I thought it would be more, but actually no. The iPhone 3G is surprisingly fast for some things. JSON is 45% smaller than the equivalent XML. Binary please is 35 smaller than the equivalent XML. And the winner is, we should have some drum roll here. In the JSON category, this is like the Oscars, JSON-Kit. No, don't think about it twice. I mean, you're working on iOS, you have to consume JSON, you use JSON-Kit. I mean, if you use any other library, we are not friends anymore. Okay, like the guy who was doing the review the other day. So please, clap. There you go. Thank you very much. In the XML category, the big winner is TP-XML, okay? So then again, I mean, clap or well, if you want, well, don't worry. I mean, it's like, as you want. In the binary format category, the binary property list. Really, if you have control over your server, you're creating an iOS-only solution, or a solution that could target iOS, and you have control over the server, and you're using good REST practices. That is, that I can send a parameter to the server to tell the server, hey, you know what, whatever you create, please send me back binary please, which is kind of the good things about REST, is about this format independence, okay? Use binary property lists. It's really worth it. It's incredibly efficient in terms of memory and the speed of deserialization, the low memory consumption, and the ease of use on the client side is really worth a try. In the network library category, personally, I have a very strong preference for ASI HTTP requests, but it's actually 10 to 20% faster than NS-URL connection, which is the standard HTTP library that is provided with iOS. Okay. Now, the problem with ASI HTTP request is that it's been phased out. The developer of ASI HTTP request, unfortunately, Ben Copsey, a guy that I happen to know personally, he told me that he's too much into work. He cannot continue the development of this library, so he recommends using AF networking, which is another open source library which is available also on GitHub. So, next steps, how would I like to continue evolving, and probably some of you would like to help me, because this is finally an open source project. I encourage anyone to use it and to download and tell me. So first of all, to test it with other server-side technology. I would like to see how this works with J2E, with ASP.NET, you know, with real web services on SOAP, to Ruby on Rails and use these kind of things, and see how we can generate different formats from these different servers. In the case of Coco networking libraries, well, of course, I'd like to test with AF networking, async socket, IPworks, Omni networking. There's a lot of, I've been finding a lot of different networking libraries for iOS all over the place. So I would like to see how they compare to each other in the same conditions. That's my objective. And then other serialization systems, because I was surprised to find so many different serialization systems. Some of them, maybe you've heard about them. Some of them, I wasn't even aware of their existence when I was preparing this project, like Apache Avro, Apache Thrift, Message Pack. Actually, Facebook has its own serialization format I discovered the other day. They are using internally for communication between their servers, but it's open, and basically they've published it as well. So then again, it would be another thing. And then test with different data sets. Could be sport results, weather, financial, hierarchical data, whatever kind of information I could find. Then again, this is something that I think could evolve in the future as well. So here's my call to action. You can go to GitHub, fork the project or clone the project, and test it in your own conditions and see how it goes. And this is the end of the story. So thank you very much. But before I leave, I would like to show you the Excel file where I have all the data so you can see a bit what it looks like. So I'm just going to go back to my Mac. the time of processing on the server side, so I'm making the difference of both, okay? When I calculate the speed of deserialization, of course, I'm only talking about the time that it takes to execute a particular piece of code on the client only, okay? Then I take all of these and I basically make statistics on top of loader speed, the data length, the perceived speed of the user. This is also very important. The deserializer speed, the consumption of memory, the rankings, finally.